let's talk a bit about performance and scale. Two very key topics. So on one hand, AKS wants to make sure that we're providing a very performant platform and one that performs well at all levels of scale, from small scale to very large scale, all the way to 5,000 and the 200,000 pods. For that, we need to provide at all different layers, from compute to storage to networking. So you can use things like ephemeral OS or premium SSD v2s for high bandwidth performance and I/O on OS. You can leverage Ultra disks and many other tiers for even more performance on your workloads. You can leverage Azure CNI overlay to ensure that you have a highly performant control plane and IPAM, IP assignment and management, and one that does not consume any IPs from your network. So unless you have any requirements to have IPs coming from your VNet and subnet, this is the recommendation that we have. And we're changing all our defaults to match this as well in the near term. With CNI overlay, you can actually get all the way to 1 million pods and all 1 million IPs as well. There's no constraints from the Azure networking side of number of IPs that it can assign. What if you have very large images? You're doing things related to AI or machine learning. You're using Java, my favorite best friend. Love Java. Love Java. Jokes aside, it also can have very big images and ones that are very, very suitable for things like artifact streaming because it has to start a JVM, has to load everything. And so it's very, very suited for something like artifact streaming, where the analogy there is something like, if you don't know it, it's like those video games or movies where you start watching or playing before it actually finishes a download. So the same thing happens here. You start the container even before it finishes pulling everything. And it starts it with all the essential things first, and then you finish pulling all the other layers. So you can start kicking off the JVM even before you finish doing all these things because you need that first. So no point in finishing downloading everything to only then kicking it off. So you can reduce a lot of your total time to start up pods by leveraging these streaming capabilities. And your total time to scale and your total performance will improve massively from things like that can take 6 minutes, 10 minutes, to bring it down to seconds, just like that. You turn it on in the Azure Container Registry side, you turn it on in the Azure Node Pool side, and they're bonded for life. And you don't need to leverage artifact streaming in all registries and repositories. You can, in the same node, download images that are streamed and download normal images too. So there's no kind of requirement or either or type of thing that you're opting into here. You can continue to use everything that you use today and start to leverage it for new images or specific workloads only. We also did a lot of work in terms of provisioning and scaling, where if you're not familiar with percentiles, I would like to be in your shoes. But basically what those mean is on the P50, it's kind of our average case. We prefer percentiles to averages and medians and things like that because they're a lot more reliable. They bring in the outliers and they don't let them escape. And so we use P50 or 50th percentile when we want to look a bit at the average case. And we use P99 when we want to look at the worst case. So that's basically what those mean, if you're not as familiar with those. So what you're looking at there is on the newer stacks of AKS, some of the newer SKUs, newer node pools with those newer SKUs, you get an average provisioning that goes under sub-minute, and it can go even lower. So that's not the fastest, to be clear. Fastest can go all the way to 38 seconds and things like that. But on average, you get it around 50 seconds. And on the worst, which is really something that we've been working on the most on, is ensuring that the worst case is very, very close to that average experience so that you don't have large outliers that you're happily one day and then massively having issues the other day. That is now 79 seconds. So just above kind of that 1 minute, definitely under 2 minutes to scale nodes and to get those nodes in the worst absolute case. Again, on newer infrastructure. Similarly, when you're scaling to things like 300, even on auto-scaling cases, 300 nodes, including autoscaler, which needs to evaluate your pending pods, etc. So this is not about provisioning time and scale time of VMs. We moved on from 3.5, again, worst case scenarios, not average, not typical, to 2 minutes on P99. Again, this is total time to scale, including autoscaler evaluation, etc., in 300 nodes scale. So it's 2 minutes to get 300 nodes on reactive scaling of cluster autoscaling. This is not you going in there and saying, I want 300 nodes. This is autoscaling, detecting pending pods, a bunch of them coming in batch and scaling up to 300. And we're going to continue to do more. In Carpenter, we already have goals to go even beyond that, and we have that even already a bit improved over it. And will continue to do that improvement on both Cluster Autoscaler and Carpenter as well. We also have improved on other areas, because again, just a quick note on scale down, because it matters for things like cost. You're going to get rid of that compute as fast as possible, because then your meters stop. So we also became 40% faster on scale down. And we added a ton of features like force deletes and force detach to ensure that it does delete and it deletes really, really fast. And as I mentioned, with auto provisioning, you actually get from those numbers even 34% faster, and with pre-binding added to it, where the pod already knows where it's going to land, so it doesn't need to wait. It just pre-binds into it. So the key thing here is make use of this. You probably don't want to be reinventing the wheel. As you saw in the demo, you want to make sure you're leveraging things like Kata. You're leveraging specific scalars that make sense to your application. You can leverage CPU and memory if that makes sense, but you can also leverage Kata and its myriad of scalars to use things like queue scaling, metric scaling, HTTP scaling, database, storage-based, anything, queue-based, anything that is relevant to your application. You can use it to scale and to even become more predictive on the scaling. You can use vertical scaling in order to increase the pod resources and limits so it can scale vertically instead of just more instances. As I mentioned that before in the demo, this allows you to not just think about VPA or vertical pod scaler as a scaling, but it also is a recommender, because it also tells you, it looks at the history of that pod and it tells you if it's right size or not. And you can look at workbooks on Container Insights and Azure Monitor and say if your cluster is green or red in terms of cost, and then run VPA in recommendation mode. And with those two things, you can very easily take a look and see, oh, I can just optimize these 5 applications, which are, for whatever reason, with requests higher than 90% higher than what their actual usage is. I can lower these requests massively, maybe even reduce the limits a bit. VPA says so based on history. And then my actual cluster becomes a lot more optimized and efficiently provisioned. Again, you want to know more about this, tune in next week, because we're going to talk more about cost there. What about, again, going back to state one more time? I think there's a pretty cool feature that I want to bring Jeff back on stage to talk about that really talks about some of the improvements that we've been doing as well on the storage and state side. We've already talked about some of them, but I think there's a very interesting one on the file side that you folks have been working on, right? Yes. Which is metadata caching for Azure files. So, oh, there you go.
Thank you.
So talk us about what is this? Why did we build this?
So the reason why we built this is we had customers that were trying to use WordPress, they were trying to use CI/CD applications, and they told us, hey, Azure Files is not meeting our performance requirements, right? And a key theme that we found these applications that were not meeting requirements was that they were metadata heavy. So these were applications where you're creating a lot of files, opening a lot of files, closing a lot of files, deleting a lot of files, doing anything other than read and write, right? Azure Files wasn't performing very well, right? So we introduced this metadata caching feature. It's currently in preview for premium SMB shares, and This feature will be generally available in H1 of next calendar year. So, so what are customers using the metadata caching for? So, we have several customers participating in the preview. They're using GitHub Actions. They're using Jenkins, and they're also using WordPress and their own line of business applications. And the results that we're seeing is they're reporting up to a 50% improvement in performance. And one use case that we're highlighting here is just using GitHub Actions to build, test, deploy applications, and using Azure Files for the storage for those artifacts as well as the applications. And one other note that I wanted to make is if you build it out here. So we do have a video posted on the AKS community YouTube that walks through using GitHub Actions with Azure Files. And thanks to George, who's here in the audience, for recording that. Yeah.
The correct George, not the wrong George.
Yes.
That's a good call out there again. And this is the kind of content that you can really ask for the community. Again, thanks Jeff and the team, and to George as well for building this kind of very concrete type of scenario and very, very helpful. So up to 50% faster is pretty amazing.
Yeah, and we continue to work on perf and scale improvements. So in addition to what's listed here, we will be announcing support for SMB multi-channel. So we've added the support in the latest Linux kernels, and we're currently in the process of backporting that to the kernel used by AKS.
Nice, very nice. We'll be talking about kernels soon as well, so that's a good segue. Thank you so much. All right, so if you want to hear more about storage and you want to know more about performance there, etc., we do have more sessions again. Expo Hall means the Microsoft booth in the Expo Hall. You can learn everything about increasing the performance capabilities with AC Store. That's on Thursday. And on Friday, you also are able to go and learn more about what are the best practices for how to use kind of storage for analytics and AI workloads. So if you have specifically analytics and AI workloads, definitely tune in for that one as well. So all in all, what kind of things do you want to be aware and take a look at to set your platform to be scalable and performant? And we already said, let the platform scale for you, leverage extensively or the auto-scaling capabilities, leverage leverage both pod level auto-scaling as well as infrastructure-based auto-scaling. Ensure that you're on one of the latest versions of SKUs. It has a dual importance. Those SKUs are already more performant themselves, but it also will do a little trick, which is it will force you to get into a lot of our newer stack because it's a new SKU. And that newer stack will have a lot of additional performance improvements as well. So when you see that, it's not just about getting into that V5 or V6 per se, but it's getting that newer stack all the way from AKS down that will get you all those numbers and benefits that I showed before. The next one is, again, make sure that you're using the right storage for your needs. We've talked about several types of storage, talked about the introduction of Plus. We've talked about ephemeral, talk about how AC Store helps you with that with pools. So make sure that you're selecting the right storage for your workload, be it read-write, read-many, single write, and read-many, all kinds of options. We have it for you. Think about, again, the resiliency. Do you need, what kind of resiliency do you want? Can it be local? Can it be zonal? Where do you want that to live? What are the trade-offs that you're good with? Then think about your networking, of course. And we're going to talk a little bit about networking in a bit. But again, overlay, control plane, ceiling for data plane if you're going to really high numbers. Then we talk about kernels. Make sure that you're using Azure Linux, one that we have full control over the supply chain. And we'll be talking about it a little bit more because we have some new announcements on the Azure Linux space as well. It's a very, very lightweight container host built specifically to be an AKS host. And we're really, really happy to have some stuff to share there as well. And then, once again, monitor. And we already shared several of the monitor sessions you can look at as well throughout the event. That's key in order to ensure that you're performing as well, is to make sure you're monitoring and to make sure that you're looking at both the control plane as well as your applications. All right, so let's move into capacity. Fun area, and how can we actually help here, right? Instead of just going in and lighting up more racks. As I mentioned, this is actually not about that as much. This is more about how can AKS allow you to be more flexible and elastic to make use of all the capacity that is available across all the regions, across the existing regions, and more. So the first thing that we actually want to talk about is, and maybe we can get Wilson to come up here as well and ask some questions on, is the announcement of a new type of node pool. It's been a while. It's been 5 years at this point since we announced the node pool type. So this is sneaky, but pretty big. This is a new type of node pools that we're announcing in AKS right now, where in the past, if you've been with AKS, and I know some of you have, I've been just talking with some of you, AKS for so long, you might know about availability sets. It's kind of where AKS was born. Then we introduced, kind of pushed that aside, introduced the VMSS-based node pools, which is what most of you are using today. And this is a new type of node pool, which is the virtual machine node pool, single instance node pool that we're introducing, which allows us to fine-grained control VMs directly versus controlling them via a VMSS. So what kind of things does that allow us to do, as an example?
So one of the main value adds there is you have the ability to have better agility in the different VM SKUs that you can leverage. So instead of having, typically for existing node pool types, you have to use one type of SKU pretty much in perpetuity unless you're going to create a new node pool. In the case with VM node pools, however, you could use multiple VM SKUs within the same family so that if you want maybe something with higher availability, in some instances, you can make that change either at the manual level or you can leverage scale profiles also at an auto level, which is something that we're developing currently as well.
Wow. So do I need to set those SKUs at the beginning, like set like 5 or 6 SKUs, or can I add more SKUs later on?
So you have the option to set them at the beginning, or well, you should set them at the beginning. But if you change your mind, something that you can't necessarily do with existing node pools, you can make that change later. And at the auto level, it can kind of make those changes for you. So pretty exciting stuff.
Very good. So now if you have anything where you want to maybe move into a different SKU in the same node pool, transition from an existing to a new one, maybe you got reserved instances in something else, and it's more of a cost conversation and less maybe availability or SKU differences, you can just start transitioning and fading out from those. Can you scale these different SKUs individually as well?
So you can do it at the individual level, pretty much the whole 9 yards. So
All
it's
right,
pretty
so
exciting
you can
work.
mix and match. Very
Yeah.
good, very good, very good. And so I think the other thing that we probably want to talk about with regards to capacity, we already showed it, right? But it's, I think the annoying part about it that everybody's asking, and already asking, like, I think I got 5 questions already in the break, is when is Carpenter and node auto provisioning going GA?
Yeah.
Who here wants to know that? Here. Okay, good. If we reach 50 hands, we'll GA it right now. Fine.
Yeah.
Not right now, but maybe close. So node auto provisioning is GA in January.
Yeah.
And maybe for those of you that are not raising both of your hands that I saw as well, what is exactly node auto provisioning? What are the things that we saw in the demo, and what does it look like?
So node auto provision is our managed add-on for use of Carpenter. So for those unfamiliar with Carpenter, it's a way to simplify your provisioning efforts. So as you can see here, you can have several different pods, and traditionally, those would go into a node pool. In the case with Node Auto Provisioner, it pretty much provisions that for you in a very optimized bin packing kind of format. So instead of it being one set type of node pool, it's essentially exactly the compute that you need at any time. And should you now, at a later point, see efficiencies, or should Node Auto Provision identify any efficiencies, then it'll adjust the size of your compute as well to make sure that you are optimizing cost and avoiding excess usage.
Very cool. And so from a capacity perspective, when I think of auto provisioning, if let's say Carpenter is selecting a D4 VM type,
Yep.
and then for whatever reason there's more capacity or more availability, or we run out of that specific type, what will Carpenter do in that case?
So Carpenter, without your participation, will be able to identify better efficiencies in other SKUs and then just move
Into
your
those.
workloads over there. So pretty exciting stuff.
Very good, very good. Well, thank you so much. Let's take a quick, yeah.
One quick question. So, we run some third-party software like Portworx and Calico Cloud.
Yeah.
So the number of node pools is also a factor in our scaling because that software is licensed. Sorry, not node pools, sorry,
Nodes.
VMs.
Yeah.
Yep.
Because the software is licensed per node. Is that something we can factor into the logic in optimizing?
Very, very good question. Yeah, oh yeah, sorry about that. So the question is, so for different types of software, thanks for that, Nate, there's sometimes factors in terms of number of nodes. And we have pricing of stuff ourselves that factors that too. And so is there a case where we can influence those kinds and give those? So yeah, Carpenter supports all kinds of hints as well. So the most aggressive way is you can literally just say, give me just prefer bigger nodes. And so we'll always prefer bigger nodes. I don't care about the family, but I want the bigger as possible. So that will do that. And then you can still force it to do different nodes in cases where your affinity and your topology will force it as well. So you can absolutely mix and match on those. You can force as well on reserved instances cases, as I was mentioning before with pools. Carpenter, same thing. You can select, yeah, sure, you can go in any size from 2 to 32 or 64 or 128 cores, as long as you stick within the D and E families, because it's where I have discounts. You can absolutely tell it that. And then you can even say that for different people. So maybe different teams will have different discounts, and you want to, again, look at cost and look at the cross-charging. So they can use different provisioners, which is what Carpenter kind of calls these concepts where you can give these influences, and different node pools even. And they can have, for one team, for example, GPU with their reserved instances, and for a different team, another GPU or another CPU with specific in their families and their instances specifically.
And kind of to that question, love all Carpenter questions. We do have a workshop that we're doing on Thursday.
We'll get there.
Okay, yes. There we go. Okay.
Say it again? We got the question.
So
we were waiting for it.
So Carpenter is kind of stepping away from the node pool kind of infrastructure, if that makes sense. And I would see the difference between the two is what your objective is. With Carpenter, you have more of a set it and forget it kind of formula that you can leverage. With VM node pools, if you want to get into the weeds of how you want to structure your nodes, then that's more so the tool that you would use. So that's kind of the distinction between the two.
A simple way to think about it right now is think about it node pool with and without auto-scaling. So with Carpenter today, you can use any SKUs, give it all the influences, et cetera. Today, with VM pools, you go in, you put your SKUs, then you scale. So it's kind of the manual scale option of it, whereas Carpenter will do the auto-scaling and the provisioning and all the pieces. It will do the pre-binding and more about it.
Why is it only compatible with Azure CNI overlay? Because on the document saying it's only compatible with Azure CNI overlay.
Yep.
But if, for some classes, if you go with overlay, you will miss the integration of Azure App Gateway, for example.
Good question. So in terms of our
So the
goals.
question is?
Yes. The question is, why is it limited to Azure CNI overlay? Is that correct? So great question. In terms of the roadmap for GA, we're actually looking to expand beyond that. So we'll offer other networking capabilities as well. So if you still want to use that, which we do recommend as kind of the most standard or most effective method of networking, you can kind of get more in the weeds and complex relative to your system.
Yep. However, before our friends in networking throw me something, that limitation is actually going away in March. So overlay will support App Gateway. So use overlay. Just stick with it.
Okay. Thank you.
All right, so let's take a quick look at then how Carpenter can make things pretty interesting. So in this case, what we have here is one of those provisioners right there. So you see here that we have AD apps, and we had families for AMD, so essentially x86 and ARM. And guess what? Which one is cheaper? Not a trick question. It's ARM. ARM VMs are cheaper. So when we apply this, and this application actually supports multi-arch, or you deploy applications, across both, you're going to get essentially the best choice across both. So let's take a look after we deploy our ARM64 specific one and our middle tier specific one there, which is one that is opinionated and one that is not opinionated. Let's see what we get. So we get those containers creating and running pretty fast. And then in terms of the actual nodes created, you can actually see them popping up there. And let's actually confirm what kind of nodes they are. And they are D4PLS, which again, if you're not fluent in Azure SKU language, that is an ARM64 type of node. Now, the reason why, and again, if you actually force it in AMD, then you can also force it to be an AMD one, as we do in this case as well. So it's very, very flexible to some of the questions here. It also helps you with resiliency and redundancy there. And speaking of kind of ARM, we also want to make sure that you're able to leverage kind of the goodness of performance, price ratio to performance that you have there, the availability and capacity we have across these SKUs. We just launched NGA very recently, Cobalt specifically. And I know a lot of you are already using it, so definitely take a look at those. We also recently had our V6 VM series out, and a lot of our newer GPU SKUs, all of them fully supported in AKS. So again, if you're not fluent in SKU, you can take a look at those and try to discern what those letters means. But I typically will recommend actually checking documentation. Those will typically mean, by the way, if you're not fluent in SKU, each one of these letters means something specific, like the type of storage that it supports. If it's ARM, x86, if it's AMD or Intel based, those are kind of the things that it typically means there. And then the first letter is typically what the family type is. So if it's memory optimized, compute optimized, if it's GPU optimized, etc. So now going back into the sessions, as Wilson was saying, we do have specifically a tutorial about Carpenter happening on Thursday at 11 in the Grand Ballroom. So if you want to get your hands dirty with Carpenter, this is a session we're presenting together also with AWS. So you can go in there and you can pick the right cloud and actually test Carpenter. And feel free to go in, and Wilson is actually one of the folks presenting there and proctoring in that session as well. All right, so security. How many days do we have left? Okay, I think we might have time for this. So again, the goals that we have is to ensure, as I mentioned before, that you have the right settings, the right controls, but also making it simple. In terms of ensuring the right settings and controls, as I mentioned, we have a lot of them. This is a little sneak peek of some of them. The bottom line is we want to make sure that there's coverage across all layers in the stack, from the images to the containers, to the control plane, the whole cluster, to the network, the objects inside of the cluster, to the nodes, the networking and state inside of the clusters, and then all the way to the application itself. So all way over 140 controls out there. These are some of them, also with recent announcements that we had. Let's maybe start with Node. And we have one Lee around somewhere. Yeah. And let's talk a little bit about one of the things that I'm actually somewhat excited that we're shipping in Node as a default, because it really speaks to this simplicity, built-in and default strategy there. And one of the things that we're announcing now you actually might need the mic. Oh, do you have it? Okay. Is the seccomp default. So can you tell us a bit about what seccomp is, maybe as a starting point?
Yes, seccomp is basically a Linux feature that allows for sandboxing of syscalls made from user space.
Very good. And what are we actually introducing here? So I believe by reading the docs that I probably wrote, that you are already able to load seccomp profiles before into AKS, right? You'd use daemon sets and all that for that. So what is this introducing that is different?
So we're going to introduce the ability to set the runtime default, the seccomp default of runtime default.
Very good.
for AKS node pools.
Very good. And so that default is, for a lot of you that might not know, the containerd default. By the way, a question that maybe warrants an AKS hoodie. Does anyone know an example of a containerd runtime default seccomp blocked syscall? An example of a syscall that is blocked. Not you, you have a hoodie. Richard, I had faith in you here. I already gave you a hoodie. I haven't given it to you yet. So these are syscalls that exemplify things like mount, clone namespaces. These type of syscalls are really, really things that containers and normal applications shouldn't really be using. Change namespace, correct. Yeah, you get a hoodie. What size do you wear?
Large.
Sure. Do I have a large? That's a large. There you go. Very good. So that's some of the examples of why seccomp is so important. And so the defaults on the runtime from containerd come all the way from Docker. They're very sane defaults, and they're things that you typically should be blocking regardless. And so with this default, you're now able to just, with one single setting, because this is just a yes or no, as Wanley was saying, that you set on the node pool, basically say every single workload, instead of loading in the security context the seccomp profile that you manually loaded, no. Every workload will now by default, if you're not specifying a different seccomp profile, will use these default one. So definitely something that, again, speaks to that default, easy, and built-in kind of mentality. Thanks, Wanley. Yep.
What if you want to do that just at init time?
This is at init time. Yeah.
So you can configure that just for the init.
Yep. Yep. So this is at node pool create time or update. You can set this up, and the nodes come up with this.
So do you get this capability FIPS enabled images?
No, so FIPS enabled will basically get you a kernel and a whole OS that is FIPS certified, or FIPS compliant in this case. And it doesn't come, so you need to load in your seccomp profiles. So there's specific syscalls that, for example, some of the standards like FedRAMP will require you to lock, but you need to lock them. So when you're doing that, you need to be the one ensuring this. This actually will allow that to be locked by default.
So that's part of the customer to the additional hardening process.
Correct. So by turning this on now, during your auditing, you now get that check just automatically marked. All right. So secure networking. I've been messing with Chase, I think, all morning. So I think now you can actually add value. Actually, see if I can turn this on. Maybe not. There you go. So
Could have added value there.
yeah, I don't know. You're the expert on that one. So let's talk a bit about secure networking. And I think in order to get a bit into that, we probably need to go a little bit into a bit of a primer of networking and some of the best practices, right? And I think starting with kind of control plane networking. So what are some of the options there?
Yeah, so control plane networking is how do you access your API server? And it's really broken down into a couple options. You have a public cluster, which means the API server is accessible over a public IP, or a private cluster, which means it's on a private IP, and you got to set up configuration through PLS, private endpoints, and things like that. There are a couple challenges with that as well. For one, the control plane, it means it's outside of your VNet, so it's always traversing over some form of connection.
So what do we recommend?
What I would recommend is next the API server VNet integration.
Very good. And
So-
what is that? How is that different than private cluster?
API server VNet integration injects the API server directly into the customer's VNet, so it's no longer outside your VNet. Everything is directly going there back and forth. You can also add or remove public access at any point, so the other options are one or the other. You can't change it once you create. This allows you to control that as well.
Chase, tell us when are we GAing this feature?
That's an unfair
This is
question.
it's an unfair question. We know a lot of you have been waiting for this GA for a long time. We've been waiting on a lot of very, very bare bones, lower in the stack fixes from networking for bugs that we identified as we develop this feature. And so those take a long, long time to roll out. However, we've have since taken a different approach. Oh, I see you here, Annie. You want to tell us when we're GAing this feature, Annie? Estimated March. So Annie is now the person that is saving us from this, because we're actually trying to change a lot of the stack that we are built atop of to receive these fixes even faster from the networking stack. So we're able to do it. So we're trying as much as we can to invent as much as we can to get this GA for you as fast as possible. So I wouldn't take that March with high confidence, but we're trying, and we're hopefully going to get there. We do support migrating into it even today. So even for dev and test and testing it out, definitely recommend trying it out already. And the question is if we support migration. We absolutely support migration, yeah.
Does that mean the API server is not going to change IPs every time you restart?
That also means that, yes.
Nice.
I have a quick question because
But sorry, let me just repeat. Does that mean the API server doesn't necessarily change IPs every time you restart it? It also means that.
as a EKS playday at KubeCon Europe, we presented a feature with EKS fully air gap.
Mhm.
Do you have any update about that?
I hope people didn't attend multiple things of these where I presented stuff. Hold on a second. Let's first talk about what you want, which depends on node networking, right? So talk to us a bit about node networking.
So node networking is how you want your cluster to access the internet. Your first option and the default right now is the load balancer. So the load balancer works great for most situations unless you create a lot of outbound connections. You do have fixed NAT ports, and for that we have node networking for NAT gateway, NAT gateway is much better in handling those outbound connections, and you don't run into the snap port exhaustion. It's not zone redundant yet. However, Ignite is coming up, and
And yes,
there's a few announcements coming up, so I would keep an ear out for things around.
it's coming in
NAT
preview.
gateway.
I'm not waiting on that at all. We've been waiting on that for a long, long time. That's a huge announcement. People need to tune in for Ignite. So yes, the Managed NAT team has been working on this for a long time, and they're previewing Zone Resilient Managed NAT, which is very excited for us. Very exciting. So definitely tune into the Managed NAT and networking sessions as well at Ignite. Learn everything you need to know about kind of Zone Resilient Managed NAT there.
Last option is UDR. If you have something like an NVA or firewall that you need to point traffic to, you can always insert your own, and that way set up your own routing. So along with other things, we're very opinionated. However, if you need options, we do provide those as well.
Now, one of the problems or gaps, I guess, with all of these outbound connections and outbound routes is that you basically get your whole cluster and node pools to go through this route, right? So you have a cluster, you have a managed NAT, you have an IP in that managed NAT, so you outbound your whole cluster through there. And then maybe you can have different managed NATs for different subnets, and you can have different node pools in those different subnets, and you can segment like that, but then you become very heavy on subnetting and node pool per subnetting. So that's not really ideal, right?
Yeah, that's true.
Okay, let's take a pause on that. Talk to us about pod networking.
So pod networking is now one of the most talked about topics that I get in questions. It's the question here that you're trying to ask when you're choosing a CNI, a container networking interface, is do you need direct pod API access when you're talking about Azure? So we recommend, as he's been saying, Azure CNI overlay, where pod IPs come from an overlay range, not a part of your VNet space. It's the most scalable. It has no impact on performance. And you get to reuse that pod space across clusters without conflict, which is great. You also get dual stack support, and which means IPv6 as well for anything requiring regulatory compliance or anything like that. That's the challenge with that for certain customers, is that you cannot directly access pod IPs. This isn't really impactful in most cases, but there are scenarios that do run into that, and so we provide other options. The next one is the flat networking model, and this is where pod IPs and node IPs all come from the VNet space. So we provide multiple options for efficiency or scale. So you have pod subnet, which means that pods come from a delegated subnet as well as nodes get their own delegated subnet. And you have dynamic IP allocation, which is for efficiency, and then as well as static block allocation, which is still in preview, but it does go scale up to 1 million IPs.
So
Then-
what's the difference between the dynamic and the static there?
So dynamic IP allocation will scale your IP allocation as your needs require. So if you scale up your pods, it's going to allocate another chunk of IPs to your cluster. And then when those pods scale down, those IPs will be back into your IP pool. For static block allocation, when the node spins up, you get a full chunk that you designate based off of your max pod IP or max pods. And those are allocated for the life of the node, so those don't do it. And so in dynamic IP allocation, you have a 65,000 IP limit, and that's been challenging for some customers, which is why we developed the static block allocation. And that no longer has that same limitation, so you can scale again up to 1 million IPs, but it is not efficient, and you need to have a really large VNet space to really make use of it.
Very good. So that's control plane, IP assignment, where do we get the IPs? What about data plane?
So the data plane is another option, and this is confusing, where in the past we've had Azure CNI powered by Cilium, and the confusion is thinking that it's a separate CNI away from that. To clear that up, Cilium is the data plane under our Azure CNI options. So you can use it in right now, Azure CNI overlay and pod subnet. And then if you're also wanting for node subnet, which I suggest, that compatibility is coming soon. So this brings improved scale and performance. It also has the built-in network policy management and also enables things like enhanced security through FQDN filtering with advanced container networking services. This is our recommended data plane.
So essentially, what I should think about today is that control plane piece is how do I get IPs and where do I get them from? And then the data plane is basically either kind of how to do the routing, which is either going to be BPF based or IP tables based.
That's correct.
And they mix and match. Okay,
Yes.
Cool. Finally,
So application networking is how do you want to access your applications? And the choice here seems binary when you have layer 4 load balancing. So if you need TCP or UDP traffic, you're going to go with the load balancer. This is, it just sets up a Kubernetes load balancer service to expose your applications. And then you also have layer 7 load balancing with ingress controllers. And this is for HTTP-like traffic, so HTTP or gRPC. You're going to want to use this.
I think someone has a question that they want to scream.
Yeah, I don't want to scream. I have a microphone now.
There you
Okay. When the Cilium network policies features will be available with Azure CNI, so like Muto TLS,
Give us
for
some more
example.
slides.
Okay, cool.
So, speaking of what we need to do in terms of more features, right? We need to jump to features. So hopefully you got a good roundup in terms of what we have as a primary networking, again, recommendations, overlay, VNet integration, especially after GAs, otherwise private cluster, and Cilium. Okay, moving on. One of the things that we've got requested a lot is for applications to be, and maybe we want to ask Shashank to come on stage if he's around, to talk a bit about this, since he also worked on this feature. And for that, most pods, by default, have access within a node to this IMDS system, this IMDS endpoint, or instance metadata. And for a lot of reasons, maybe Shanky can share some of the reasons of why is it a concern from users that their pods have access to IMDS, or the instance metadata endpoint. Or maybe firstly, what is the instance metadata endpoint?
Yep. The instance metadata endpoint, like from the VM days, it's supposed to give you metadata information about the VM, and it is also used for getting a few access tokens as well. But that's the thing; it was not like necessarily meant long term for how the pod should be authenticating, and having access to that IMDS endpoint can like open up vectors of attack for, especially with respect to how your access tokens are procured, and with that, like whatever those access tokens have permissions to, you'll be able to access those as well. So we ideally want the pods not to do that, and to instead go for an approach where they don't rely on like long-term credentials, but rather they use work identity federation and use that as a form of authentication. Now,
So if you thought that you're going to get all beautiful portal demos, Chase and Shashank are going to bring the CLI hard now. All right, so talk to us about what's going on over here.
Yep. So here we're using the new. Can you hit play? Yep. So here we're using the IMDS restriction preview feature on this cluster. We are setting that up over here. And once that's done, we are going to give a demo of how, if you're using host network, you're still able to access the IMD's endpoint, but the pods using host network, it should be very small.
Why
and-
does host network still access the IMDS?
Yep. So there are still a few components which would require access to the IMDS endpoint. So for those, we don't want to turn off host network and basically break all those dependent services.
And so the node
that's-
itself as well, right? So the bottom line here is the node needs access to
Yeah.
that IMDS endpoint. So pods that reside on the same namespace as the node still have access to that same namespace. So if you put something in host network namespace, by design, it has access to this. If it's not in host network namespace, and by design, it does not have access to this namespace.
And
so what's going on over here?
Yes, so we are deploying a pod with having access to host network, and from there we'll demo getting access to the IMDS endpoint. And while that's popping up, in terms of best practice, we don't want all of your application workloads to be having access to host network. So this is only for the dependent services that we were talking of. So over here, we were able to curl the IMDS endpoint and get the results. So that's the first part. Now it's the part where the IMDS restriction feature that we had turned on comes in. So we are deploying a pod which doesn't have access to the host network, and we'll try to do the same curl request here again. And this time around, it should fail.
The anticipation is killing me. Oh no, Cuttle. 28, did we fail?
Yeah, this time around, yeah, we are not getting any response from that.
Yeah, so 28 is a timeout from curl, essentially. All right, so thanks, Shashank. So now, for that problem that I asked you to put a pin on, which was the whole cluster needs to have access to outbound today because of the need for outbound, that it's still required, at least for a few more slides. And if you want to granularly define your outbound, today you kind of need to do the subnetting per node pool, which is kind of annoying. It would be great if you could actually have a deployment and have that deployment have its own egress IP, and then maybe add that to a firewall on the other side, maybe have a different deployment have its own IP, then have that IP going there, and do this for private and public. Can you do this?
Now you can.
Very good. So tell us about it.
So static egress gateway, it allows you to make sure that you can control your egress traffic. So before, as you mentioned, you'd have to send everything through something like a load balancer, and everything is coming from that individual IP, which makes it difficult to set up any access controls for sensitive resources, anything like that, because you'd have to whitelist an entire IP range, that means all traffic coming from any of those nodes or pods is going to be available to access a resource. With static egress gateway, now you can designate pods or deployments to go through the gateway, which will set a specific IP range or an IP prefix. And instead of having to allow access to the entire range, now only those pods will go through that gateway, and you'll be able to constrict access only to those specific pods.
So you're challenging the black screen CLI with a white screen CLI? Is that what's going on? All right,
Those are the guidelines.
go for it.
So right here, we just have a basic cluster set up. It does have static egress enabled. And so now we're going to add a node pool specifically for the gateway. And you're going to set the mode to gateway, which means that nothing else will be able to be scheduled on it. And you're also going to set your gateway prefix to the specific amount of nodes that you're going to want. It's kind of cut off, but.
There we go.
So you're also now going to set up a specific public IP prefix, and this is going to be the one that you're going to assign to the gateway node pool, and that way you'll always be able to confidently say this IP prefix will be able to access these resources.
Let me see if I can
It's a
fix that a little
little-
bit. This might just mess our whole presentation, but heck with it. Let's try it.
It's perfect that it's not working.
Yes. Okay, so my mouse is gone, so that's good. Can I get a mouse back? Yes, no, okay. I don't want any of these things. Yeah, it's there, but I don't want this, go away. There we go, I have a mouse. There we go. There we go. Hopefully this is now visible. Let's go back into it. This is a very delicate operation. Hold on. Hold on. Give it a little bit. All right, we see it. So maybe start over now with us actually seeing what's going on.
Okay. So this is just a basic cluster, nothing special set up, with the exception that static egress gateway is enabled. Now, again, we're going to add the node pool and the Modis gateway. Nothing will be able to be scheduled on it, preserve it. You're going to have a node count of 2. This can go up. Right now, you can set an IP prefix between 31 and 28, and that means that's the limit of how many nodes you can have. And you can see right now we have a prefix of 30, and we're only doing a node count of 2 right now. So after this, we're going to create the public IP prefix that you're going to assign to the gateway node pool. You're also going to match that to the length of 30, and that'll keep it in line with the prefix size that you want.
So you can get IPs, private and public, and you can also assign it, statically, public and private.
Yes. If you don't assign something manually, one will be created for you. However, that means that you didn't define it, and if something happens and you recreate it, then it will be created automatically. Right here, we're going to define the gateway configuration, as well as showing that we have the annotated and non-annotated pods. So one workload is annotated to use the static gateway, and the other was not. We're going to apply the workload. We're going to create a test web app to represent some sort of sensitive resource. Right now it's a secure DB, and it's just an echo server to make sure that we can test connection. So right now we're going to configure the restriction, and we're going to make sure that only the prefix that we want can access it. And as you can see, we assign the prefix address that we had before. And we have the allow and deny rule that we're going to show right now. I'm going to go into the web app. And right now, you'll see right at the bottom there, when we go down, you'll have an allow rule only for the prefix that we want with the highest priority, and deny everything else. So only our pod should be able to access this resource. And right here, as I said, we're going to go back to the CLI. And we're going to test the non-annotated pods. So these ones are not going through the static gateway. And as you can see right here, you get the error 403, it's forbidden, and we've been blocked from accessing it. Now we're going to test the annotated pods, which any deployment, any pod specifically, will be annotated as it comes up and down. So anything brought up here will go through the static gateway. And you can see that it receives the response that we expect.
Very cool. So in addition, so this is leveraging a gateway pool that is taking care of all this networking, and it's a fully managed pool by AKS.
Yes.
And this also, for all of you that are Istio users, will be integrated into Istio egress gateways, which will be able to not only apply policies into egress flows, but actually integrate with this to have both static egress and policies, L7 policies on those egress flows. So you can kind of get the double whammy there for egress control. Very, very granular. Thank you, Chase. I can leave it on with Shashank, because going on to the other thing that I did present and I did hinted at the last KubeCon, which is we still have this need for outbound access, in particular for servicing. Whereas a lot of the different things that you might have, like add-ons, you can private link them into the VNet. Most services, including ACR or Azure Monitor, you can private link them. And we did have the ability, as Chase mentioned before, to have UDR, which you could forward to a firewall and very granularly restricted to those specific endpoints that AKS requires. However, that's still a bit of a cumbersome configuration, and we wanted to do, again, better, easier. Again, it's in the same flow as before. We want this to be simple. We want this to be by default. We want this to be built in. And so we're very, very happy to finally kind of present to you network isolated clusters, which are clusters that you can create with 2 new outbound types that Chase didn't present. And those 2 new outbound types are very simple. They're called none and block. So none, as the name indicates, sets up no outbound whatsoever. In fact, it's deployed in a private subnet. And block, not only does it not configure outbound, but it throws in an NSG that denies outbound access to it, just for added control and security. What about if you're in your own subnet, which is typically the case? So this is for managed subnets. If you're on subnets, that means that you can add yourself your own NSG or firewall control, of course, for L7, to control that outbound and basically restrict it to everything. And that does not impede AKS to actually continue to service these clusters because AKS is making use of a pull-through cache feature that makes all the binaries and container images that AKS needs from MCR to be mirrored and cached in an ACR registry that you can then private link into your cluster VNet. So now they are all serviced privately. So let's maybe go a bit into the demo. If you can walk us through it, Shashank. It's going, I think. Maybe, maybe not.
No, it's not.
Ooh, there you go. There we go.
Okay, wait, the resolution's off.
It's going to improve, hopefully.
Okay. No, it's really, really off.
Tell us what's happening.
So right now, we ran a command for setting up network Azure clusters where, no, it's really off, man.
You don't need to see this anyway, CLI, ugly stuff.
Uh,
There you go.
Oh, okay. Got better. So we ran a command to set up network Azure cluster. So the bootstrap profile had cache over there. So we are using the pull-through cache.
Maybe I can get you this restart and get you to show the command. Maybe. Don't think so.
Okay.
Still weird.
The first few seconds of the demo hates us. But yeah, we ran a command to indicate the outbound type to none. And
Trust us.
we are using the managed option in over here. So we support both the managed ACR where we set up everything for you, or you can
There you go,
like, bring your
outbound
own ACR as well. So over here, we'll like show that there is the
There you go.
pull-through cache being utilized and the container registry ID. Now,
Let's show that cache.
yep. So now it's showing for the subnet that's created, it's private over there. And now we are going into the container registry, and we are going to show the pull-through cache being set up, and the
Right
source
there.
registry path is mcr.microsoft.com. So all the images that are being pulled from that had to be pulled from the MAR before are now getting pulled through the pull-through cache. So your entire node bootstrapping process doesn't require any access to MAR at all from now on. Yep.
So that means that all our images that are in MCR can still be pulled.
Yep.
Do we need to change the image names or anything or tags?
No. So you don't need to do any of those things. So your entire node bootstrapping process, all you have to do is set up the network Azure cluster mode.
Okay.
Now, for the next part of the demo, we are like showcasing that if you're trying to pull in images from like an external source, like let's say Docker Hub, it will fail. So that's what this part is showing right now.
Mm-hmm.
And then next, we'll try to do a similar kind of an image pool, but from MCR, but the actual image is first getting cached into your ACR and then coming through. So think of like your add-on images and other like components that we use as part of the features. So all of those images will come through from the pull-through cache.
Very good. And so this is still going to be like an mcr.microsoft.com type of
Yep.
image, but it would still kind of magically go there. Okay.
Yep. And the pull-through cache itself, so the cache is getting like pulled from the MCR images, and all of that happens over the Azure private backbone. So none of this is happening
Yep.
anywhere over public networks.
Very, very good. All right. So And then with block, we basically do the exact same thing, but there's that additional
You-
MSG there.
Yeah,
Very,
we
very
block
good.
all the network access.
Very good. And we want to now talk a bit about what our advanced container networking services are. So we continue in this trend of security and networking, and we have this suite of things that we announced literally a year ago at this point. And what kind of announcements do you have for us, Chandan?
Yeah, well, so networking is kind of air, right? And I think ACNS is oxygen, right? To boost the productivity, to simplify management, debugging, and secure your network. Especially it's critical in terms of Kubernetes and containers when we are building microservices, we want to secure the microsegmentation architecture, applications. So how do we bring the focus back to simplifying it, securing it for you? So the platform we're building is like, we announced open sourcing it in the last KubeCon we call Retina, where we embrace some of the open source initiative and then commoditize it across all data planes of CNI, across all OS. And with ACNS, we are giving that as a managed offering. So you can secure your traffic, you can observe, troubleshoot your traffic, especially in the constraint where IPs are changing dramatically and the deployments, and you have tons of application to manage, so you can operate it at scale.
Very good. I mean, networking is there, and ACNS is
Oxygen.
oxygen. Oh, that's just, love it. So it's based out of Retina, which is an open source project, so that you can install anywhere, a BPF based,
Yep.
right?
Yep.
And what kind of things can it do? Show us more.
And today, yesterday itself, we saw an announcement. There's a big announcement like, hey, it is available, generally available, and then I'm super incredible proud of the team that we have all the things, the key features available right on the box, including the DNS stack, and then how your workloads are using network consumption across your nodes, the pod level filtering, pod level DNS filtering. You can have, instead of tracking which IP addresses you want to track, you can actually do all this advanced features. The Retina and ACNS build on open source technologies, right? Very heavily in eBPF, Cilium. Actually, in fact, the Retina is actually bringing Cilium. I mentioned Cilium's have a capability across all Windows and other CNI data plane as well. But we also, with ACNS, we give a managed experience with the Azure Prometheus. Azure Managed Prometheus, or bring your own Prometheus. You have out-of-the-box dashboards given to you to know what kind of clusters, what kind of applications you are deploying, how they are behaving, and you have a support from different alerting things we have in Prometheus and Grafana. We have support for Hubble, the flow logs, where you can capture the rich information about the 5 tuples going by different applications. And again, it supports both Cilium and non-Cilium clusters, including Windows, which is critical for some of our workloads.
Okay, so that's something that triggered me right there.
Yep.
To support Hubble?
Yep.
Like all of Hubble?
Yep. Well, so Hubble has a piece where you kind of observe the traffic through the CLI and the relay and how aggregation and all this work, right? So that is out-of-box supported in here. We don't deliberately install the Hubble UI, which can give you the service map, but folks can deploy it if they are
Self-install
custom
and
to
deploy
it.
the
Yeah.
UI, yeah.
So we, by default, the experience is that you can use the Azure Managed Grafana and Prometheus, but Hubble UI is also people can deploy on top.
Yeah, so you have Grafana and Prometheus, so we don't want to install more components. You can install it if you prefer the Hubble UI. You can use the CLI out of the box as well, as you can see in this example as well. Cool.
Yep. So let's go on the next one. As part of ACNS, we're also giving the FQGen filtering, which is also generally available now. So traditionally, it's get very complicated in the containers and Kubernetes world, where you had to constantly manage the IP addresses. And with DNS filtering, you can just whitelist your domain and then forget about IP addresses on the high. One other unique feature about FQDN filtering in ACNS is we provide HA by default. So it's, even if your DNS proxy is down, it is able to give you high availability of DNS resolution on demand.
Filtering
we are
keeps
actually-
happening even
exactly.
if DNS is down.
Exactly, and we are,
Which is, DNS is always a problem.
yeah, and we are bringing it back to Cilium as well. We are bringing all this capability we have in ACNS back to open source. So Cilium open source will also have this HA capability, which is only today being provided through some product offering, but that work is also happening.
Very, very good. All right. What else we got?
So
Time for a demo.
Yeah, let's have a very quick demo of the FQDL filtering, right? So this example, which we're going to demo in this one, the app will be able to talk only to Bing.com and not Google.com. Well,
As you should. One
as you
has
should,
proper
right? The Bing is
first-
better. So just click on this.
Yeah.
Okay. So here we are showing that what the pods and nodes looks like, and then we don't have any network policies applied today in the basic vanilla version on top, and there is no Cilium network policies applied as well. And then we're gonna exit to the pod and then try to access Google.com and Bing.com both should resolve. And the first one is a call to Bing.com. It is responding as usual. Then we have a call to Google.com, and it is resolving as well. Now what we're going to do is apply some network policy which is going to restrict the Google and allow Bing.
It's not going to be like your typical just label-based, IP-based network policy.
Exactly. Right? This is going to be DNS-based, going to be using it's showing right now that we applied this one, we are dumping it, and there is a match port, a match application for my app, and then it's saying the match pattern is star.bing.com. So any traffic going to bing.com should be allowed, and the rest of it should be blocked. So this is the key scenario. You don't want your malicious actors or things running in your containers to go talk to the world, and then you can restrict their access. And there is no need of IP address filter listing. And as we applied it, now we're trying to go to google.com, and it should be refused. It can't resolve the host, and the access can't go. If you go to the
Hopefully this is now Can't find. Okay,
Yep.
good.
Yep.
So to a lot of the questions that we got, right? So on DNS policies, DNS-based policies, and moving on to L7, question is also going to come to L7. That is something that we're working on, and we get the full L7 capability out soon.
Yeah.
And so this is kind of the start of a lot of those capabilities on the security space
Absolutely.
as well.
And this is just the start of all the capability we're launching, including L7 encryption and all those things which we can provide part of ePPF and data plane.
Yep.
Can you identify which is the encrypted traffic versus unencrypted traffic within the cluster using Cilium?
Which is the encrypted traffic for your MTLS. Once we start to enforce the L7 policies, then we'll have those kind of metrics available. Right now, it is not looking at the application level protocols. It is providing just the DNS filtering. Yeah. But once we enable the L7 policies,
The next feature on this.
The next feature on this, which
will
is hopefully should be coming early next year.
So I'm trying to avoid having to have different network policy enforcement on OpenShift versus TNZ versus AKS. Are you working actively as part of the admin network policy working group to get, right now I believe that lacks the DNS. Yeah. But the tiering that you get in admin network policy is quite useful.
Yep.
So.
Yep. Correct.
My first answer is always just use AKS across. Makes it so much simpler. But yes, to that point. Yeah.
So and one of the reasons why we are choosing to go with the CRD of Cilium right now, because it's widely getting a cross-class thing and all that, but there is a part of working group of admin network policies. We are trying to bring it back to the native Kubernetes as well. So you can have part of the vanilla spec covered that. So yeah, but that work is still ongoing in the community.
Good.
Okay, so very quick demo on debugging, right? Like, as I said, ACNS is oxygen. It has to boost your productivity. So in this demo, a very quick demo, we have a Contoso front app, which suddenly stopped working, and we are trying to debug it. So let's see. So
That must be a lie, because that app is perfect. It never fails. But I'm curious, what happened?
So we have this application is deployed as a service in AKS, and it is using ACNS. It is using Azure Prometheus Grafana. By the way, ACNS supports bring your own Prometheus as well, but we have a very native integration if you use Azure Monitor and Azure Prometheus Grafana. So somebody applied, while I was talking, somebody applied there's an English rule that, hey, we have storefront is not gonna run, and suddenly this application is down. But as a developer, you don't know why my application is down, who applied the network policy which are doing that. So then you go to the alerts, which is you have configured. If my application is down, this is a sub-1 that, hey, Contoso app is not reachable. Right away, it detects that, hey, your application is down and gives you alert, and then you're looking to go to Azure Prometheus Grafana to find out why the application is down. And I was mentioning that ACNS has a bunch of dashboard built in for you, right? So you have DNS workloads, and then for this particular case is the drops workload, right? So, hey, why traffic is dropping, and you can see that, hey, I have a historical that start to see the traffic is dropping because of the policy denied error. So you can actually even get a reason of why the drop is being observed in the application. And that gives a hint that, hey, some policy has been done there, and then I try to look at the policy. Of course, in this demo, we have just one policy, which is Janai storefront, to show that, hey, this policy is dropping all the traffic. But you can imagine that this kind of error from humans and then error from this is very easy to troubleshoot. And as soon as I delete this application, the network policy, the Contoso is back. So hours are off for troubleshooting, starting from detecting it from the alert, all the way from finding it is now much easier.
And again, all those dashboards, they're there, right? I don't need to go create that. Okay, great.
Their dashboards are there. The alerting is like you can create and fine tune based on your scenarios. So it's like much rich, and use the standard Prometheus stuff.
Great. I like watching at them. I don't like setting them up. As usual, I mean, I like to say it's typically the user error, right? It's typically user error.
Oh, absolutely. You have a very rich DNS dashboard, historical context of the DNS, not only at the pod level, even like, hey, what domains you're resolving from the node, from the pod, what is latency you're observing, much richer DNS metrics. Okay.
Thank you, Chandan.
Thank you.
One reminder, if you want to know more about this, we do have several sessions on networking throughout the event, which include also more on ACNS. So we have on Tuesday, Hubble Beyond Cilium. Again, we already got some of the hints of what that kind of might mean. Grand Ballroom B. On the Expo Hall, once again, we have securing microservices using eBPF and Istio. And we also have cloud agnostic observability using Retina, which, as Chandan mentioned, is the open source project that backs this ACNS suite. And then I would also call out the AKS networking best practices session that will expand a lot on what Chase started this section with, and a lot of what we cover here, and go a bit more in detail into that as well. And that's also on our Expo Hall on Thursday. So let's go into secure supply chain. And firstly, I'd like to talk a little bit about Azure Linux as one of the announcements that we have there, and one of the key points. So Danva, if you come in. Obviously, one of the key points in our supply chain is our container host, right? Tell us a bit, just a quick primer on what is Azure Linux.
So Azure Linux is Microsoft's Linux operating system. We started the project around 3 years ago to solve a supply chain challenge within Microsoft. And all the AKS services internally that George referred to are running Azure Linux. So it's Microsoft's home-built Linux operating system. We pull from upstream sources, and we build everything securely.
I love that you also got to the actual dress code, and I love it that we're all going there. And so what are we announcing today?
So today we're announcing something we actually released just a week ago, which is Azure Linux 3.0 on AKS. So last year when we GA'd this, it was Azure Linux 2.0. We periodically take a look at some of the major upstream components that we deliver, so things like the kernel, Containerd, Runc, all of those got major bumps. Containerd 2.0 just got released. So that prompted us to release new version of Azure Linux. It's in preview on 1.31. It's going to go GA on 1.32. And just some quick benefits. We minimize packages on Azure Linux as much as we can for AKS. We only load secure kernel modules that are signed with Microsoft keys, so we don't actually allow random kernel modules to get loaded. There's a 5-day SLA for CVEs. And before we release any packages, we actually run through the full AKS end-to-end test suite, so you won't get faulty package updates.
This is pretty important because, again, it's a full control over our supply chain in that level of the container OS. Of course, this is not necessarily saying we're going to get and deprecate Windows or Ubuntu, but it's definitely great to be able to have a kind of homegrown Linux distro that we can get all these guarantees from, and really excited to have 3.0 about it. Anything you're excited as well, kind of come with features with Azure Linux that you want to kind of call out?
Yeah, I mean, the biggest one I want to call out is just Containerd 2.0, which
Ooh,
is
yeah.
the default on Azure Linux 3.0. So on major distro versions for Azure Linux, we don't upgrade Containerd, so 2.0 will stay on 1.6. But 2.0 has a lot of improvements, things like user namespaces, better block I/O performance, and a lot of our customers have been asking us for that. So that's
NRI, hooks, all that
exactly,
stuff.
yeah. So that's the biggest one I'm excited about for this upgrade.
Yep. Not excited about the tests that are going to fail, but excited about
Yeah, exactly.
definitely 2.0. Thank you so much.
Thanks for having me. Thank you.
Let's talk a bit about, obviously, a key piece of that supply chain, which is the registry, and namely the Azure Container Registry. So thanks for getting close, Toddy.
Simple questions only.
Simple questions only.
Yeah, I
10
cannot
second
answer
answers.
hard questions
Yes.
when
Elevator,
I'm hungry.
Elevator style,
So-
absolutely. So what do you got for us? So how are we simplifying the actual supply chain thing? So one of the things that I think everybody in this room that is using ACI have been wanting for a long, long time, right, is repository permissions.
Yes.
So talk to us about a little bit how this works.
I don't know, I was wondering whether I should call Nelson here to talk about that, but in the past, so what we used to do in the registry is you have like a couple of roles that you can apply, and whoever actually is assigned those roles have the access. Typical is if you, let's say, have ACR pull permissions, you can pull anything from that registry. It doesn't matter whether you own the image or not. And if you have push permissions, you can push to any repository inside the registry. Now we are changing this with the new thing that we call attribute-based access control, and we can go and limit the access to just a namespace in the registry, which means that if you have multiple teams that are using the same registry and you don't want them either accidentally or for other reasons to override their images, you can restrict the access based on a namespace.
Very cool. So now different teams, different access, different pieces on the repository.
And yeah, now you can actually use one single registry and make it like multi-tenant as anything else that's in the cloud, and you don't need to create a bunch of registries for every team.
Very good, very good. So next we have, I think, a very key point then on this supply chain area, right, which is continuous patching. I'm really excited about this one. It's a big problem, right? You create images. We just saw the demos at the beginning. Create the Docker file, create the images, deploy them, but then what's next?
Well, I don't know whether you know, but sometimes images don't get patched regularly, let's put it that way. So what we do is we use an open source project called Copacetic. So Copacetic is, or I think the new name is Copa. It's part of CNCF. What Copa does is actually takes the image, cracks it open, applies the fixes using the package managers, and creates a new image that you can use with the applied patches inside. What we are also doing in ACR is we use the ACR tasks so we can automate this so you can run it every day. So you can go and create tasks that actually go and patch your images on a daily basis, and you don't need to wait for the upstream project to actually patch them. Once they patch them, you can take the patched image from the upstream project, but sometimes it can take 2-3 months for the upstream to actually patch it, and normally you have some deadlines to follow for patching if you're...
You might be asking, who's using these kind of things? We are. AKS, in our day-to-day, we're using these kind of things today. We're using things like Copacetic and Dalek and a lot of the open source projects that come from Toddy's team and our upstream teams. And that brings me to one thing, which is you're going to be doing a little bit of a good roundup of these things in the keynote, right?
Yeah, that will be Thursday morning at 10 a.m. So
right there, Hal D&E at 10 a.m. Always late, so if you're late, just still go there. It's going to be probably at 10:30, but that's what time is in the schedule. And it's going to be a good roundup. And then if you want to go into more details on supply chain, again, Expo Hall, we have a ton of good sessions out there with enhancing the security of your container images with continuous patching, which is exactly this feature, just expanding a lot on it. Unlocking binary drift detections, amplifying the security of deployments using Ratify, which is also an open source project that kind of ensure the provenance of images, and Gatekeeper, again, our policy, the core of our policy solutions. And then finally, ensuring that you also get to know more about Azure Linux and the expansion that Sudhanshu just said. We have a session discussing everything about Azure Linux on Thursday as well. Thank you, Toddy.
thank you.
And to kind of wrap up, we want to talk a bit about vulnerability assessment. And we had Shashankin, you can sit. I think people have seen you. They know you. That's fine. I think they got that I know what I'm talking about. I don't think I'm fooling anybody. So we do want to have one key thing. Again, we're going to talk a lot about announcements on our security suite, namely on our Microsoft Defender for Containers next week at Ignite. Did I mention that Ignite is next week and there's a session? And one of the parts of that session is secure. The other part is cost. So if you have interests in these areas, definitely tune into that one. Also, I hear there is a great speaker in that session, and the other one is Brendan Burns. So that's great. So it is really good to have a lot to announce in this space because it's a crucial area. And the one that I picked for today for you here is our vulnerability assessment capabilities, which is for a lot of what Toddy just mentioned and for a lot of what Sadamba just mentioned in terms of our supply chain and our container hosts, we want to give you the full visibility of what are the CVEs there and what do you need to do to patch them. So most of them are our responsibility, but we want to tell you when we're patching them, where this is in the outline. So we're pretty excited about this. And furthermore, we want to have something which we're kind of dubbing as the AKS Security Blade, which will give you this and a lot more, such as compliance status of your clusters, whether they are complying with security best practices or not. And maybe you can walk us a little bit into this quick demo as well. So I think we're going to basically see a little bit of that security assessment tool sets, and hopefully this is visible and not too there. It's small.
It's a bit blurred out.
Yeah, so this is basically that view that you were seeing in the slide, and these are all CVs that we have there. And based as you kind of double click on those CVs, you see the different severity. In this case, high, medium, etc. You're actually going to be able to see what's their status upstream. Are they patched? Are they not patched? Are they waiting on an upstream patch, and therefore we are also waiting on that because it can be from an upstream component? Are they already patching that upstream component and you need to upgrade your nodes? Is it waiting on an AKS release to get patched? And you get all of that information in this page in single blade. And then you can, of course, expand this from, this is a cluster view, but you can then expand this across all your clusters. You can incorporate this into your fleet views, so you can have a multi-cluster view of all your vulnerabilities across all your clusters and know what you need to do as well, very granularly.
Yeah. So the scope of the images and the scope of the vulnerabilities that are being assessed over there. So the nodes and the packages, and also for your container registries that like you have covered as part of the Microsoft Defender for Cloud. So those are getting scanned not only at the container registry, but also the workloads are getting deployed to the cluster as well. And soon, like even the add-on images that we anyways already do scan internally before we roll out, but even those are going to get displayed on your security vulnerabilities that we are surfacing there, and you'll be able to like see the risks of each of them and so on.
Yeah. All right, I do want to get us to lunch. And so if you want to know more about these security solutions, be it assessment, binary drift that we talked a bit before, if you want to know more about threat analysis, we have a lot of those as well in the expo hall, in the expo area. So amplify security with Ratifying Gatekeeper, we mentioned that before, unlocking binary drift detection, getting more visibility, which is exactly this kind of feature with Microsoft Defender. That's all of these are going to be at the expo hall. And then we also have on level 3, 355B, on Friday, working together to improve security visibility in Kubernetes from Rita and a lot of the security kind of chairs that are going to cover a lot of what's coming next in upstream in regards to security. And we're going to have a lot of great stuff there. So hopefully this was informative. This is kind of, once again, a repeat on what our wheel of things is. You can go away. And hope that we were able to get some of that knowledge to you, for those of you in value, that for those of you that the first time here, for those of you the second time.